on to solution stoich. So this is stoichiometry, just starting with solutions as opposed to the solids that we've been using before. I have an additional example up on, if you're familiar with, I think it's called Eduscape or something like that. Show Me Creations as well, the apps for the iPad. But I think it's kind of nice for my students to have all of this stuff in one place. So I'm going to put a video up here on YouTube as well. So this is an example of a type of problem that you might see that would require you to do solution-based stoichiometry. Notice it gives me two substances that are being reacted, ammonium hydroxide and calcium nitrate. It says that they are mixed, so they are in fact reacting. This means that my first step in solving a problem like this is going to be exactly the same as when I was dealing with two solid amounts being mixed. In fact, those two solid amounts would have to be dissolved in water, creating effectively a concentration, moles per liter, of the two substances mixed. So believe it or not, you've actually been dealing with solutions the whole time. So in order to find out the mass of my solid, I got to figure out who the heck my solid is first. So ammonium hydroxide is reacting with calcium nitrate. This is a 1, this is a 2, so I need 2 of these. So let's see here. NH4 goes with the NH3, and calcium goes with the hydroxide. There we go. Plus 2, minus 1, plus 1, minus 1. Yay. Balance that real quick. 2 there, 2 there. Huzzah, that was easy. Now to figure out what the heck my solid is. Rule 1, everything involving ammonia is soluble, so that's not it. Nitrates, also soluble. Nope. This one has an ammonium and a nitrate. Nope. Hydroxides are solid. There is the solid that we're talking about. Now, if you remember a typical stoich problem, we would start with whatever unit that they gave us and proceed to convert to moles. So typically, we would start with grams of whatever my reactant is. And our first step would be to convert to moles of that same reactant, then on to moles of the product, and finally onto the unit that they asked me for. In this case, mass of my product, which we'll just say grams. Product. So this is the map that we would use. 3 arrows means 3 conversion factors. But if you'll notice up top, I don't have grams. Instead, I have a volume and a concentration. That's 2 very different units from this grams that I'm usually talking about. But look at this first step. This first step is to convert from grams to moles. So from whatever unit they gave me for that first reactant to moles. So that seems to imply that somehow I'm going to use these 2 numbers here to get to moles of my first reactant here. So if we think about this for a second, this here, can you see that in my camera? Let me move my paper down just a bit. Anytime you see that capital M, we can actually rewrite this as a conversion factor. This is the same thing as saying 2.5 moles per 1 liter of my ammonium hydroxide. So this is a ready-made way to convert between moles and liters. Well, they didn't give me liters. In fact, they gave me milliliters. So that seems to suggest that in our situation, instead of this typical path, my first step is going to be to get my milliliters to that slightly more usable liters. From there, our molarity, using this relationship here, is going to allow us to convert to moles of my ammonium hydroxide. And from there, my path is going to proceed as it does up above. So moles of my reactant, here I am. So this right here replaces this step here. So you're actually not doing anything different. You're just swapping out units. That's all. So let's see, moles of our product, 2 grams of our product. So we have 1, 2, 3, 4 arrows means I'm going to need 4 conversion factors in this problem. First one's pretty easy, milliliters to liters. Notice I haven't involved any of the numbers from the problems yet. Here they come. This step right here, going from liters to moles, is where I'm going to use my molarity. Molarity is a ready-made conversion to go from liters of our solution to moles of our compound of interest. So those are the big guns. Let's see, next here we got to go from moles of reactant to moles of product. Step 3, this is our mole ratio from our balanced equation. 2 moles of ammonium hydroxide, because there's a 2 in front of my ammonium hydroxide there, equals 1 mole calcium hydroxide. It's getting near the end of the school day here, so if the bell goes off, I apologize, and we will continue when it's finished. Last step, molar mass, nothing unusual there. Calcium plus 2 oxygens plus 2 hydrogens gives me 74.1 grams of calcium hydroxide per that 1 mole. So now we're ready to go off and set up our boxes. So here we go. Start off with the number they gave me. There it is, 150. So first step, milliliters to liters. There they are, 1,000 milliliters. 1 liter goes on top. And remember, you don't have to do all this bookkeeping here. It's just a nice way to keep your thoughts straight until you have a better handle on where you're going next. 1 liter, there it is. Our 2.5 moles of ammonium hydroxide goes on top. Next, we want moles of ammonium hydroxide to cancel. There they are, 2 moles. Ammonium hydroxide, 1 mole. Calcium hydroxide, 1 mole. Calcium hydroxide, 74.1 grams of that same stuff. Equals, whoops, can you see that? Sort of, kind of, there we go. Let's multiply all the way across the top, divided by all the way across the bottom, not minus, times you dumb calculator, divided by. So that gives us 13.89 grams of our solid. But I have 2 reagents that are limited. Oops, there we are. 2 reagents that are limited that I have added. I don't just have a free open flow. There actually is a fixed amount, so I got to figure out which one runs out first. I don't know if this is the answer yet. I got to do this whole setup again for my second reagent. So again, they started me off with a volume and a molarity. So we are going to use this bit here to replace this bit here. They are equivalent. So, same concept. We started off with milliliters. Going to take them to liters. That's not good enough. We got to get to moles. This time we're talking about our second reagent, the calcium nitrate. From there, we're going to our same solid product of calcium hydroxide. Okay, here we go. First step is still going from milliliters to liters. Step 2, liters to moles. This is where our molarity comes in. For calcium nitrate, it's 1.75 moles calcium nitrate per liter of solution. Step 3 here. In front of both compounds, I have a 1 as a coefficient, so this is a 1-to-1 relationship. Always nice and simple. 4 is going from moles to grams, so that is the same as the previous. Huzzah! Gosh darn it.
Teachers, please pardon the interruption. The JV boys baseball players, the bus leaves today at 2:45.
So now you know the secrets of our bus. Alright, so start with the number that they gave you. Don't ask me why I put a 0 there. That doesn't go there. So converting to 1 liter took care of that one. 1 liter on the bottom, 1.75 moles calcium nitrate takes care of that one. 1 mole calcium nitrate to 1 mole calcium hydroxide. Almost there. Last step to grams to, there we go. Multiply all the way across the top, divided by all the way across the bottom. Gives us 16.21 grams of our solid. Can you see that? There we go. So, two answers, 13.9 and 16.21. Since this one is my smaller number, this is what actually happens, making my limiting reagent. The compound that gave me that, my ammonium hydroxide. There's our bell. End of the school day. Congratulations. This one does not happen at all. I will try to post a couple of more problems dealing with the solution Stoich type stuff, because next we're going to be calculating amounts of ions within these solutions. So not only calculating solid products, but also looking for ions left over. If you have any questions, I know I did this problem kind of fast, but please post them in the comments section and I will get back to you as soon as humanly possible. Happy stoiching!